orbital diagram, we've learnt that we can split our energies or our shells into different levels. Okay, and we've said if you look at the periodic table, that periodic table can tell you what's actually happening in terms of the quantum level that you're actually in. Okay, so if we look at the first period, we had a maximum of 2 electrons. We looked at the second period, we had a maximum number of electrons of 8 because we had 8 elements in that period. We looked at the third, again it was 8. We looked at the fourth, it was 18, and so on, until we got down to the sixth, in which case it was 32 because we had these lanthanide block in here as well. So what we actually looked at was, if we look at the quantum levels, or these are called energy levels, we can look at how many electrons we can have in each energy level. So we can have the first energy level, then much higher energy level, second, third, and fourth, and so on, and we can just keep going. Right? First energy level, we can have one orbital. Okay, and that is an orbital that can contain 2 electrons. So an orbital is something that can contain. Okay, right. So then in our second, both an s and a p orbital. Okay, so we've got both s and p. So in our second, we can have a total of 8. And in our third, we can have both S, P, and D, so we can hold a total of 2 plus 6, which is 8, plus 10, which is 18. And in our fourth, we can have a total of 32, because we have 2 plus 6, which is 8, plus 10, which is 18, plus 14, which is 32. Okay, so we can then split these orbitals into different types. Okay, so my S orbital is just a sphere. Okay, my p orbital can split into 3. Each p orbital can take 2 electrons. So my px orbital can take a maximum of 2, my pz orbital can take a maximum of 2, and my py can take a maximum of 2. Okay, and these are called px, py, and pz because it depends which axis they're on. So that is on the px axis, that's on the pz axis, and that's on the py axis. Okay, and we can use that to construct what we call different energy level diagrams. So we can look in a bit more detail as to what an energy level diagram is actually going to look like. Okay, so this is our energy level diagram. And each shell can take a maximum of 2 electrons. Okay, so if I electron configuration where you could have up to 2 electrons in that subshell, up to 2 electrons in the 2s, up to 2 electrons in the 2p, and so on. Okay, so we could look at, for example, the electronic configurations for different elements. Okay, and we could say, for example, my electron configuration for helium was just 1s. For lithium would be now what you had put as 2 in the first shell, 1 in the second. We are now putting as 1s2, 2s1. Okay, because remember, my first shell is an s orbital, my second shell is an s orbital, but it is in the second quantum number. Okay, and what you would have put for oxygen as 2 and 6, okay, because oxygen has an atomic number of 8, we are now putting as 1s2, 2s2, so that's 4 in total, 2p4. Okay, you will learn a special rule when we look at nitrogen and oxygen, for example. You will see that each of the orbitals in P, so Px, Py, and Pz, each of those are half-filled before we completely fill any orbital. Okay? So what I want you guys to have a go at is looking at what the electron configuration diagrams, we call these box diagrams, are going to look like for the first 36 atoms.